Good morning, everybody. I am Dr. Uday Kumar Khan. Today, I am going to discuss about the study of Lissajous patterns. So, first, I am going to discuss about the theoretical aspect of Lissajous patterns, and then I am going to give you a demonstration of how to get the Lissajous patterns in a trainer board with the help of a cathode ray oscilloscope, CRO. So, let me start with a very simple circuit. Is an AC circuit having two components R and C. So we have RC circuit where R and C, a resistor and a capacitor, are in series, and one source is connected, which is the AC source. Then the capacitor has a current value which is in phase ahead of voltage supplied to the circuit. This phase phi is tan inverse 1 by omega CR. And if we look at the signals, that means the voltage signals, this Vs is this sine wave and the voltage signal across C is Vc, and this is the following. So, if we look at like this, then there is a phase difference. When this signal is maximum, that means the original signal is maximum, this Vc is not maximum here. It is maximum at this point. Therefore, this signal is leading with respect to this original signal. And so there is a phase difference between the two signals, and mathematically, if we write Vs like this, V0 cos omega t, and Vc, if we write like Vc cos omega t plus phi, then this phi is the extra phase which is related with the frequency of the original signal omega, the C value and R value, with this formula phi is equal to tan inverse 1 by omega CR. Now, if we apply the two signals along the X and Y channel of a CRO, cathode ray oscilloscope, in a CRO there are two plates along x-axis and two plates along y-axis. So if we apply one AC signal along the x direction and other one along the y direction, then what we get is the superposition of two simple harmonic motions acting along right angles. One is along x-axis, other one is along y-axis. But we have chosen the two signals having the same frequency omega. So in this case, superposition of two simple harmonic motions acting at right angles to each other having same frequencies. And this phi can be varied with the help of variation of R or variation of omega. But in this case, we will be changing the phi value with the variation of this R value. That means this R will be variable for our experiment. And then, if we look at the oscilloscope, then what we get is this kind of patterns for different phi values. This pattern we get is a straight line with phi is equal to 0. Then ellipse we get with phi is equal to pi by 2, and this another ellipse with inclined major axis that we get at pi by 4, and then again straight line we get when phi is equal to pi. With this circuit we can get these three patterns, but to get phi is equal to pi, this circuit won't be able to give me the same phi. That's why I have taken another circuit. This is using IC 741, that means operational amplifier, in an inverting amplifier mode. In this case, this is operational amplifier. Pin 7 and 4 are biased with plus VCC and minus VCC, and inputs are given between 2 and 3, and output is taken from 6. So there is one feedback resistance here, RF, and another resistance R1. So the gain of the circuit will be minus RF by R1. So in this case, AC signal is applied in this terminal, like through R1 between 2 and the ground 3, and therefore the output will be 180 degree out of phase with respect to the input here because of this negative sign in the formula. So this straight line here is for phi is equal to 0, and this straight line is for phi is equal to pi. So there is 180 degree phase shift. So what we do here in this experiment, we take two signals. One is called X signal, another one is called the Y signal. X signal is the original signal, and Y signal is the voltage developed across the capacitor. Similarly here, we take the X output from the pin 6, and the Y output is the original signal. So in the oscilloscope, in the two channels, we have to feed X signal and Y signal, and we have to take the oscilloscope in XY mode. So this way we can see the pattern in the oscilloscope screen. So now, I'm going to give you the demonstration. So for that, let's do the experiment. Okay, this is our trainer board to study the Lissajous patterns. So it has one sine wave oscillator having frequency 1 kHz and voltage 10 volt peak to peak. And this is our first circuit I showed you in the whiteboard. So where I will apply this signal into this AC network, this is RC network, this variable resistance here, and C is here. This C can be kept connected with the circuit or can be removed by this on off switch here, and there is another extra arrangement here. So another resistor is kept here in parallel to C, and that is also optional, that can be kept on or off putting this switch on or off. So the purpose of this R will be clear later. So we have to take the X output signal from this end with respect to the ground, and Y output signal from this end, that is the across the capacitor with respect to the ground. So this black part is the ground, and then we have to take the two signals X and Y output in this oscilloscope in channel 1 and 2, and we have to take the XY mode of the oscilloscope, and we'll see the pattern. And the other part of the circuit is the op-amp. This is inverting amplifier. So this is IC 741, and as I showed you all the components I discussed in the board. So here also you can take the X output from pin number 6, and Y output is our original signal. So if we want to get the Lissajous pattern for phase phi is equal to pi, then we have to take this circuit. For other phi angles, we have to use this circuit. So first we will see the pattern with the help of this circuit. So let me first connect the sine wave to the original circuit, RC network. And then I have oscilloscope 2 channels. This is my X channel. So I am taking the output from this, and then Y channel, Y output I am taking from this area. And now I switch on here. So this is in now XY mode. Therefore, okay. So we have two outputs, X and Y. What I showed you in the board, see, there is a phase difference between the two signals. When this capacitor is kept on and some resistance is applied to the circuit. So you can clearly see the phase difference here. Though both the signals are having the same frequency, but there is a phase difference. So when yellow one is having peak here, the pink one doesn't have the peak at the same point. So there is a phase difference. So now this is the XT mode or YT mode. Now we have to display it in the XY mode. Okay. So in XY mode, we have to make sure that this channel 1 and channel 2 are in same scale. So both are at 10 volts. So now I am making them at 5 volt scale. Okay. And okay, so we are getting this pattern. This is a Lissajous pattern. Okay. So what I am adjusting here is this resistor. So when this is 0, made 0, then we get the straight line, what I showed you in the board. That means then phi is equal to 0. And then if I increase this, then the ellipse is back. Okay. Okay. So for different phi value, we have ellipse of different major and major and minor axis, and inclination is also different. I mean the inclination of the major axis with respect to the x direction is also different. So we are getting here, and to get the other part, okay, we can do one more thing. So this capacitance value we have taken 0.5 microfarad, and this variable resistance can go up to 10 kilo ohm. So we can do one more thing. If we switch off the capacitor and switch on the resistance, then what it gives is a purely resistive network. So there is no phase difference, and so the phi is equal to 0 because it is a purely resistive network. There is no capacitor. So this part is resistance, this part is also resistance. Then we again get the straight line what we have got earlier also with this capacitor on, but this R value is 0. Okay, then to get the Lissajous pattern for phi is equal to 180 degree, we have to switch to the other circuit. So I am putting this off, this off. Okay, then I'll take the signal from here. So my X signal will be taken from here. I'm putting this off first. And then Y signal from here. And this is the common terminal. Now I'm putting this on. Okay, here I have to put the signals. Okay, so I'm getting the Lissajous pattern for delta phi is equal to 180 degree. So this is to get the various pattern and to study the pattern, like all the phase angles we can analyze for these curves, taking this data into a PC or into a laptop from this oscilloscope. So we can transfer all the images which is visible here into a PC or laptop, and then we can analyze all the pattern, and we can also calculate for what phi value or phase angle we are getting what type of pattern. So this analysis can be done with the help of a computer, and we can plot also in different way by using different type of plotting softwares. Okay, so here what we have done, we have studied the Lissajous patterns for different phase angles of the two signals. One is X signal and another is Y signal. So this CRO has two channels and there are 4 plates. So along the X-axis there are 2 plates, along the Y-axis there are 2 plates. So we are feeding the channels into 2 plates, like along X-axis plates we are feeding the X signal, and along the Y-axis plates we are feeding the Y signal, and that's why we are getting this pattern. So let's go back to the board once again. So we have studied the Lissajous patterns for superposition of two simple harmonic motions acting at right angles to each other, having same frequencies, with the help of a RC network, RC AC network, and with the help of an op-amp inverting operational amplifier. And we have seen the patterns as I discussed earlier for various phase angles of the two waves, and for R is equal to infinite or highest value what we have in the trainer board, we have seen the pattern was here like this. So when R is maximum, then we get the phi is equal to 0 and we get the straight line pattern, and for phi is equal to pi 180 degree we get this pattern, and then for other phase angle phi we get this type of patterns. So we are able to understand how the Lissajous pattern can be obtained with the help of superposition of two simple harmonic motions. So I hope you will be able to perform the experiment in the laboratory and students will be very happy. So thank you for watching this video. Have a nice day.